In this tutorial, we are going to talk about creating a simulation for your ZW3D design using SimLab Composer. This is a jigsaw power tool designed in ZW3D. Under the SimLab tab in ZW3D, click Transfer to export your design to SimLab Composer. In SimLab Composer, click on the Simulation bench to access the simulation options. You can either choose the parts you need to simulate or click Detect to automatically convert any objects to solids that can be simulated by the physics engine in SimLab Composer. Click on Links to start adding joints and connect the parts of the model. Notice that hovering over the objects now highlights them in red, indicating that they are solids and can be simulated. Before we start adding joints, let's go through the mechanism of this jigsaw. The electric motor connected to the small gear will start revolving, forcing the second gear to rotate as well. In turn, the second gear and through the pin on it will force the vertical metal part to move. And since the vertical metal piece is constrained, it will only move vertically, moving the blade of the jigsaw along with it. Click on Revolute to create a rotating joint. In the panel to the left, for Solid 1, click on the blue globe. For Solid 2, click on the electric motor. Then click on the ring of the gear to determine the axis of the revolution. In this case, it will be the x-axis. Click on Enable Motor and set the speed to a constant of 5. Setting the ground as the first ground solid in this case means that we want the motor to generate the rotation by itself and not to be influenced by the rotation of a different solid. Go to the Simulation tab and click Parameters. In the Parameters box, set the gravity to 0, since this simulation does not require a gravitational force to run. Click Start to play the simulation. The first gear is rotating now, but we need it to affect the second gear. To do so, click on the Revolute joint and click on the blue globe as Solid 1, and select the second gear as Solid 2. Set the axis of motion by clicking on the ring of the gear. You now have a gear that is pinned on its axis and is able to rotate along the axis you choose. The second step is allowing both gears to interact with each other, and that can be done by enabling the collision on both gears. Select the gear and click on the Enable Collision icon. Select the other gear and enable the collision property for it as well. If you click play, you can see that the second gear is now rotating along with the first gear, but the fixture connected to it is not moving. To connect the pin to the gear, click Fix to create a fixed joint, and then click on the pin to set it as Solid 1, and then on the second gear to set it as Solid 2. Now that the pin is connected to the gear, select it and enable its collision. Select the vertical metal part and click on Enable Collision to force it to interact with the pin. Select the base that is stabilizing the vertical metal part, and click on the lock icon to prevent it from moving and set its collision to enabled. To add further restraint to the vertical metal part's movement, click on the prismatic joint button. Select the vertical metal part as Solid 1, then select the base as Solid 2. The prismatic joint allows the solid to move only in one direction, which is the type of movement you need for this object. All that remains now is connecting the blade holder and the blade itself to the vertical metal piece. Create a fixed joint and set the first solid to be the holder, and the second solid to be the vertical piece. Do the same for the jigsaw blade. Click Play to view the simulation. SimLab Composer's simulation is very simple to use and can provide very accurate motion and objects interaction, using advanced mathematical and physical equations embedded within its engine. It can turn your ZW3D models into living objects that won't require traditional methods of communication to explain, but rather a simple play button.